Okay, as I go over this, I would love for you to fill out this slide. You can play this video while we are completing it. So this is the same slide as the one that we just talked about previously about those ordered pairs. But notice this time we are going to talk about the function. What happens to the function and writing the function when you make these translations. So previously we were looking at what happened to the ordered pairs. Now we're going to write the function change, okay? And what you need to remember is that y is equal to f of x. Y is equal to f of x. So we're going to want to know, is the change on the y value or is the change on the x value? So let's look at translations. Let's look at moving right 7. If we move to the right 7, what value is changing? Is the x value changing or is the y value changing? If we are moving to the right 7, that means our x value is changing. So the change is on the x value. So our f of x is now going to change the x value, not the y value. So the f of x is still going to be there, but the x value is going to be changed by the amount that you're moving. Now here with the right or the left, you have to remember that that's the opposite sign. So if it's going to the right, it's going to be minus 7. So our new function would be f of x minus 7. What if we're moving to the left? Again, a left or right is the change on the x value because you're sliding with that x-axis. So our f of x is now going to change to f of x with the number, but here again, left is going to be the opposite of what you think, so we are going to add 4 here, adding 4. So left and right is the only two that are just the opposite numbers. Now, why does that happen? Well, if you take a look at Desmos, you take a look at a graph, and you put in these numbers, you will see that you're actually shifting those, the whole graph is sliding over. So your ordered pairs are just moving down the line, but you are adding to the x value and subtracting from the x value when you move them. Okay? So let's look at moving up, sliding up and sliding down. Is the change on the y value or the x value? If you're going up or down, you're changing your y value. Your x's stay the same. The x values are going to stay the same. That's what we saw in the ordered pairs. So our f of x moving up is now going to be, remember f of x is y, f of x is y, our x is going to be the same, but our y value are changing, so our y is going to be adding 5, moving up. So we are changing our y values. So let's write that as a new function. So let me get rid of that. So f of x, whoops, is now going to be f of x, because that's our y value, plus 5, because our y is doing the changing, not our x. We're not changing the x value, we are changing the y value. When we move down, the same thing is going to happen here. We are not changing the x value. We are only changing the whole, the y value. So f of x is going to be moved down 3. So the y value, remember f of x is the same as your y value, okay? So y is being changed. Your x value is staying the same. We didn't change the x value like we did over with the left and the right. The x values were changed over here inside, see? So that is the difference between moving left and or moving right. So let's talk about our reflections now over the x and the y axis. What is being changed when we reflect over the x-axis, remember our x values are staying the same, but our y values are changing. The y values are being the opposite signs. So again, our f of x, our y values are changing. So now what happens? If the y values are going to be opposite, that means it's going to be the opposite of the function now, because our x values didn't change. When you're reflecting over the x-axis, your x values stay the same, but your y values are opposite. Now over the y-axis, your x values are going to be opposite. Your y values will remain the same. So our f of x is now going to be f of negative x, because your x values are changing when you are reflecting over the y-axis. All right, now let's talk about the dilations. The dilations are a little bit confusing the way they're worded based on the ordered pair to the function. So when you have a scale factor of 1/2, that is causing your ordered pairs to reduce. But your graph is going to be stretched. So this is a stretch here, because it's going to take you longer. If you're say you have a parabola and you had all of these points here and that they are being divided by 2, it's going to take you longer to get to those points because you're climbing slower. So that's why your graph is going to be stretched out. So your f of x is being multiplied by 1/2. So your y values and your x values are being multiplied by 1/2. So that's, let's look at it this way. That's like saying 1/2 of your f of x and 1/2 of your x's, right? So if I factor out that half, I'm going to delete that so I can have some room, then I just have 1/2 of the entire thing, f of x. So everything, the whole function, is being multiplied by that scale factor. The same thing when you multiply by a larger number, your f of x is going to be multiplied by that scale factor. So everything gets multiplied. This over here is a enlargement of the ordered pairs, but it is a compression dilation. It is a compression. Because if you have your original graph, let's use that parabola again, but now we're going to be climbing faster. These ordered pairs are going to be multiplied by 2, so I'm going to get there a lot faster, and I'm going to compress my graph and make it more skinny. All right, so let's see how you can practice this new knowledge on this next slide, where you have a little quiz about these ordered pairs and the functions.